Okay, hello everyone. So my name is Nicholas Corsepius. Of course, I'm your professor for this course, and this is our first week of real content here. So let's dive into it. The courses, of course, organic and biological chem, those are going to be the big focuses. We're going to start the first few chapters here focused on organic chemistry before we transition to start talking about biological chemistry. And so this chapter is going to be about introducing you to organic chemistry and what is kind of the most fundamental compounds that you will find in organic chemistry, the hydrocarbon. Okay, but first let's talk a little bit about what organic chemistry is. So organic chemistry traditionally was the study of chemicals and components of life, right? So that's where that word organic comes from. And traditionally, historically, this really comes from this idea that early chemists had that molecules that are produced by like the human body or by something living are very different than those that you're going to find outside in nature, for example, in rocks and all that good stuff. And they weren't really too far off, but then eventually what happened is someone was able to synthesize a molecule that was found in human urine using sort of what would have been traditionally inorganic techniques. So that line has been a little bit blurred over the years. It turns out that these fundamental, there's not really anything magical about life, although the molecules that are typically used in living compounds do fall under a particular umbrella, and that is that they contain carbon and hydrogen. So that's really what organic chemistry has sort of become throughout the years. It's not necessarily just like the molecules with life, which is the traditional meaning. Right now, organic chemistry is the focus of organic compounds, which necessarily contain carbon and hydrogen, and in particular, a carbon-hydrogen bond has to be in there somewhere, okay? In addition, an organic compound may also contain something like oxygen, sulfur, nitrogen, phosphorus, or a halogen. Really, any one of the other non-metals can be contained in an organic compound as well. And in life, we also find organic compounds in things like oil and gasoline, which, oil does come from the earth. As well as it's used in plastics and perfumes and all that other good stuff. So there's a wide medicine is exclusively organic compounds. So there's a wide range of uses for organic compounds. Again, this idea of organic versus inorganic has shifted over the years, but the most important thing is an organic compound necessarily contains carbon and hydrogen. And then there's some other like broad differences that we can talk about when we're talking about organic compounds versus inorganic compounds. So organic compounds typically are, actually always organic compounds have covalent bonds. There are some inorganic compounds that have covalent bonds, but all organic compounds have covalent bonds. When we're talking about inorganic compounds, most of the time we're talking about salts. So things that are held together by ionic bonds, okay? Ionic bonded compound salts have really high melting and boiling points, right? You can't really melt table salt, sodium chloride. Whereas organic compounds have lower melting and boiling points. So what does that mean in terms of how we interact with them on our daily lives? Well, organic compounds can be gases and liquids as well as solids, where inorganic compounds are typically just solids, right? They have really high melting points. So they're almost always just solid. Organic compounds can also undergo combustion, so they're flammable, right? By virtue of containing carbon and hydrogen, those compounds are combustible, whereas you can't light table salt on fire, right? Sodium chloride. So inorganic compounds, specifically ionic compounds, are non-flammable. And then organic compounds also tend to be nonpolar and thus are not soluble in water. This isn't always true. So for example, I could have something like, so this is methane, this is certainly not soluble, but if I were to erase this hydrogen here and replace it with something like an OH group for an alcohol, that may be soluble in water. So there are certain functional groups that will make a organic compound soluble in water, but typically, broadly speaking, organic compounds are not soluble in water. And on the flip side, Mostly our ionic compounds are soluble in water, right? Ionic compounds are made up of those ions. They can be dissolved into water or other polar solutions. So this is basically saying the same thing, just summarizing it a little bit more. Again, like the one thing that really defines an organic compound is the fact that it contains, in terms of elements present, carbon and hydrogen. Inorganic compounds will contain both metals and nonmetals, right? So in terms of if you're looking at the periodic table, they'll have something from one side and something from the other. Organic compounds only have those nonmetals. Again, they're held up by covalent bonds, organic compounds are, compared to ionic bonds. Typically non-polar compared to the ionic bonds. And again, because they're made up of ions, that makes them, it's not really polar in the strictest of senses, but makes them soluble in water. Melting points are way lower for organic compounds than they are for ionic compounds. So look at this, sodium chloride. If you really wanted to melt it and make liquid sodium chloride, you'd have to go to 800 degrees Celsius. You're talking about temperatures that are like on the inside of the volcano at that point, right? Nothing that you can even achieve through lighting it with a lighter or something like that. And again, in terms of flammability, organic compounds can undergo combustion, so they are flammable. They will burn in the presence of oxygen, whereas ionic compounds do not. Okay, so just a little learning point here. If we're going to categorize these as being organic or inorganic, everybody take a second and see if you can't figure that out. Okay, so if it has a high melting point, what would that be? High melting point, we would expect that to be, oops, can't spell, inorganic. If it's not soluble in water, that would be our nonpolar organic. Contains carbons and hydrogens, well then it's definitely organic. Has the formula magnesium chloride, so it might have been a while since you guys have busted out a periodic table, but that would be a good idea right now, is to look at your periodic table and see if you can't determine if something with the formula MgCl2 would be organic or inorganic, okay? Magnesium lives all the way on the left side of the periodic table, whereas chlorine lives all the way on the right side. So that's a metal and a non-metal, so that's inorganic. And easily burned in air, again, organic compounds undergo combustion, so that would be organic. Okay, so that's really just the skills that I would expect you guys to have at this point in this course. This first lecture video isn't so bad compared to what the rest of the chapter will be, but that's really the skills that I expect you to have now, is to be able to categorize based on these features, whether or not you would expect a compound to be organic or inorganic.